Hello everyone, my name is Raghav Ankur, working as a National Manager with Foundation for Innovation and Collaborative Education. Today's webinar is on Cloud Analytics and IoT. If you see the domain of Cloud Analytics and Internet of Things, you should understand what are its applications. You should also understand what are the tools and platforms that you can use, whether it is open source or made by some uh, various vendors, uh, so that you can design IoT applications. So for to understand this webinar, let's understand how this webinar is structured. Now we will be talking about market segment and use cases of Internet of Things. Then we are talking about what are the typical components of IoT, and what are the Intel platforms and tools available for Internet of Things applications. We will take one example as a case study where we will use Intel Galileo as a cloud analytics platform. And then we will also and discuss about IoT and cloud analytics platform that is supported by Intel. So the typical market segments of IoT, if you see, the major component is a industrial automation. So then we come about the smart city solutions. We have smart energy solutions, connected transportation. We will be talking about these days smart agriculture in IoT. Connected buildings is in home automation is one of the market segment of IoT. Smart healthcare, retail and supply chain. We have various applications. We have various applications in healthcare, wearable and consumer electronic segments. But if you see overall market picture, the four segments: one is industrial automation, smart city solutions, smart energy solutions, and connected transportation. They are the major driving factor of IoT in today's world. So when I talking about industrial automation, so in industry you see the various things, whether it is a office equipment or machinery, or if you are inside a mines, coal mines, they are all connected with each other. Most of these devices are giving a data, and this data is handled by gateway based solutions or the database management or IoT based platforms. And this is how the various devices are giving information to you so that you can utilize those informations. Similarly, smart city solutions, we talk about smart traffic, smart utility bins. We are talking about city safety is a major driving factor in smart city solutions. Similarly, smart energy, we talk about Wi-Fi energy meters, smart energy metering solutions, smart grid solutions. Then similarly in connected transportation also you find various applications like location tracking of vehicles, fleet management, geofencing. So these are the some of the four major segments and its related use cases that are available. So let's take one example of the fleet management system. So in most of the fleet management systems, we have a some of the main key focus areas like rising fuel and maintenance cost is one of the driving factor. Driver as passenger safety is one of the driving factor of IoT segment, and then customer service is a major factor. So if you see the architecture of fleet management systems, definitely your driver is on board, your passengers are on board of the bus. You require a Android based APIs or Android based applications in fleet management which we give to the clients. Similarly, each and every passenger required to know about the location of the bus. Okay, we require a dedicated bus tracking application for the passengers we can provide. And most of the buses, they are GPS enabled. So and they also has bus operator can run a cloud or private cloud system. So there are various things that you can do and you can help in designing such type of applications. Now let's understand in data management, in case of intelligent fleet management, what we require. We have to require manage data associated with vehicles, number of vehicles, who driver schedules, passengers, terminals, and stops. So all these information, this is what the relevant data for us. Similarly, you should require a optimized routes and stops locations. You have to assign work shifts to driver based upon their availabilities. So similarly, in mobile application, after passenger login, driver will get list of passenger waiting in the bus stop. Passenger will also get continuous alert about the bus arrival time at source and destination. You can search a bus route which is ideal for you. You can have a post ride feedback feature, which is a most of the important feature as far the customer service is concerned. Then important aspect is a vehicle telematics, and this is a major domain where the real-time data processing happens through various sensors. You can estimate the fuel consumptions. You can detect the potholes using accelerometer data. Similarly, driver behavior monitoring you can detect using the accelerometers. You can detect whether the driver is driving harshly, or it is over speeding at what moment. So these triggers or these sensor data are very helpful in telematics. Similarly, smart surveillance is a major factor where you can stream the video of the passengers inside the frame. Also, you can say you can send the video one frame per second over 3G 4G network to the control center for further help. So so it means data management, mobile applications, smart surveillance, telematics. These are the one of the major areas where the intelligent fleet management systems uh, actually uh, require to integrate it. Now, there is another important use case of retail and consumer behavior. So we call it as a floor sensor analytics. No, for everyone visit the shopping malls, and in the shopping malls, what happens? Uh, you have a particular inclination towards a one particular product, and you can capture the movement of the customers in the shopping mall, which are coming um, to know about the product. Okay, so there you can put a pressure-based floor sensors that can capture the movement of the customer and its behavior. Okay, and then you can identify the pattern and opportunity for growth. For example, let us suppose if someone is standing in front of the product for a longer than 1 minute, and you can display competitive pricing, or you can send a text SMS to a nearby sales associate so that that salesperson can guide the customer or educate the customer about the benefits of that product. So in a major IoT scenarios, uh, you are sensing, you are analyzing, and you are engaging the customers. So in this application, we are using a pressure-based floor sensors to sense the movement of the customer. Similarly, you are analyzing the pattern or behavior, and you are looking for the opportunity for growth that will yield your brand impact and a brand value. And you can improvise on the rate of return. Similarly, you are engaging the customer in the last by observing its behavior, its patterns, and you see that there is an opportunity that this customer can buy our product. So you can engage that customer by displaying a competitive pricing and sending a text SMS to the nearby sales associates. So this is another retail and consumer behavior use case that I have depicted here. Now, if you see the architecture of such type of applications that you need to design, so there are the things are coming, then we have a gateway, there is a cloud. So in a very first, things are the devices that takes the data, mostly analog signals, and digitize them. And because most of the data is in a digital form. Okay, so the role of the thing is to get a sensor device data and convert it into analog signal and then digitize it using the inbuilt ADCs. And most of the MCUs or microcontrollers, whether it is Intel Quark CPUs are there or Intel Galileo or Intel Edison development boards are there, they are actually has inbuilt ADC capabilities. Similarly, gateway solutions comes into picture when we are getting a data from the multiple sensor nodes. And this the main aim of the gateway is to push the data to the cloud by using a very famous HTTP post and get methods. And also in most of the cyber physical systems, you see that gateway also has a tendency to response to a device like actuators. Then for cloud analytics and generating of reports or customer behavior analysis, we have a cloud-based systems. So this is a component of Internet of Things architecture. One is the things are concerned, then we have a gateway, we have a cloud-based solutions. Now let's highlight this in a very different scenarios. We have devices, they do require connectivity. So connectivity is definitely there. We talk about 3G and 4G connectivity, GPRS connectivity, Wi-Fi, Bluetooth. There are multiple connectivity options available for the devices to take the data from one device to another device or to the gateway solution. And we have various protocols like HTTP protocol or MQTT, which is a lighter bit or lighter version of the HTTP protocol. You can design a custom protocol also to take the data from any device to the cloud-based system. And then we have at the farther end, we have the application segment where consumer has a mobile app, and your mobile app is actually taking data or forwarding data uh, uh, from a server or a cloud platform. So in a nutshell, if I talk about platforms and tools for IoT, what we actually require, most of the things they need to process the data, and this is a physical world. So most of the things take the data from the physical world, and most of the data is analog in nature. So we require a support of analog interfaces within build ADC support. We require PWM, GPIO support in most of the microcontrollers and platforms uh, that are used to design the things, or which are the main building elements in as far as things are concerned. Similarly, we require a support of Zigbee, NFC, Wi-Fi, Bluetooth, and other wireless protocols that helps you to take data wirelessly from one device to the another device or to the gateway. Then here comes the Intel-based platform solution, which is Intel Quark-based SoC that has a low-power processor. It has a 32-bit technology running at 400 megahertz, and it has a well-supported architecture in terms of it supports embedded communication protocols. It supports a legacy interfaces that most of the Intel IA32 architecture processor supports, and it is the first product in a market segment that has a Intel architecture uh, which is meant for IoT market. So when I say the scope of the Intel Quark-based SoC, which is Intel Galileo, so it can interact with the physical world very easily. You can interface accelerometers, sensors, GPS, and GSM modules. It supports a SPI, I2C, UART, and other type of serial protocols. And moreover, it supports a IoT applications through Wi-Fi support is available through Ethernet interface. So now let's talk about cloud analytics using Intel Galileo and how we can design a IoT applications. What are the various components that Intel provides to develop a IoT applications? So when I say IoT cloud analytics, it includes a resources for the collection and analysis of sensor data from the Intel IoT developer kit. And when I say a developer kit, it is a component of, it's a set of sensors, it is a hardware board, uh, it has a software packages, libraries that actually helps you to design or take the data from uh, um, uh, any development board to uh, uh, IoT analytics platform. And similarly, there is a IoT agent is a software that helps in getting a data from Intel Galileo board through internet and transfer it to the IoT analytic platform using HTTP or MQTT protocols. So if you want to integrate Intel Galileo with the IoT analytics, what we require is we require a dedicated libraries. We require a IoT agent software which is installed on Intel Galileo board, and and you can easily transfer data from Intel Galileo device. You can integrate any sensor through analog interfaces or digital interfaces of Intel Galileo or Intel Edison and take the data to the IoT analytics platform. So for this to work, you need to create a Intel IoT analytics account. So there is a dashboard that will help you to log in your device or register your device first in the Intel IoT Analytics platform. So when I say registering your device, you are registering your Intel Galileo board with the uh, IoT platform or an IoT agent with the um, IoT Analytic platform. Then if you don't have an IoT kit agent in your Intel Galileo, you can install it, the agent from GitHub. The link is already mentioned. Then you have to start a agent when you install it, and there are some commands available that will help you to start and stop a IoT kit agent on an Intel Galileo development board. Once you start a IoT kit agent, what you need to do is you can test the networking capability, whether your device is connected to the internet or not. So IoT kit admin test is test the network connectivity. You can get your device ID that you need to register to the IoT analytic agent or IoT analytics cloud platform. So you can get the device ID. What is your get device ID? If you want, you can change it or you can retain it. And when everything is done, there is a one tool, we call it as IoT kit admin, that you need to initialize. So that you can your IoT agent which is present or IoT agent which is present on Intel Galileo platform, that will initialize first. Then you can activate your device. So if you see, if you log in into the IoT analytics platform as a normal user, you will see the activation code, and you can view this activation code. And this activation code will help you to activate the device on a so that there is a link established between the IoT kit device, IoT agent, which is sitting on a Intel Galileo, and the IoT analytics panel. So there is a command, we call it as IoT kit admin activate, and then followed by the activation code. So this will help you to, this is a command that will help you to activate the device on a IoT analytics platform. Then you can see the catalog. So generally the components or catalogs are the components that are registered with the, uh, um, you can say your accounts. For example, here the default component is registered is humidity, power switch, temperature. And also you can create a new catalog also depending upon which sensor data you want to uh, take to the IoT analytics platform. For example, if you want to take humidity sensor, you can put a humidity component here, because this is how your Intel Galileo is going to recognize the IoT component. Then you have to register a component. So once the component template is already there, you can register the component here. So in order to register the component, what you need to do is you have a command which is called IoT kit admin register this this temperature dot b1 dot 0, it is already there. So you need to register the component as a temperature. So there is a linkage between your uh, Intel Galileo sensor and the Intel IoT component catalog box by means of this. So if you send a observation also, you can send a IoT kit admin observation temp 35. When you send this observation through your command line, which you can access through FTDI cable in Linux environment, so you will see the temperature of 35 and 30 is going to be uh, uh, uploaded onto the IoT analytics dashboard. And you can see overall the temperature ranges and all those things you can see in this. So this is how you can visualize the data. You can see the data, what is the degree Celsius. You can have the past 10 minutes data, past 1 hour data, past day data, past month data. You can see all the data that is uploaded by Intel Galileo on this IoT analytics platform. Now, as far as cloud analytics platforms are concerned, Intel Cloud Analytics is a one of the platform, but you can integrate Intel Galileo with IVM Bats and IoT by using IVM Bluemix Cloud Service. Similarly, Microsoft Azure IoT Cloud Service is also well supported by Intel Galileo. Then AWS IoT Cloud Service, which is well supported by Intel Edison Development Board. We call it as Amazon Web Service. Then there is another open source platform, which is TAP, is an open source software optimized for performance and security, which helps you to create a cloud native applications driven by big data analytics. So these are the other, apart from Intel IoT XDK, there are other type of 4 platforms I have shown here, and that is well supported by Intel Galileo or Intel processors, which are based upon Intel Atom or Intel Quark. You can view some of the resources that I have mentioned here. If you want to know more about Intel Cloud Analytics, you can visit the website. There we have a IoT Cloud Analytics website is there. So there you can see and you can actually implement the experiment what I have performed that I have shown here. So if you have any question or a query about this webinar session, and if you want other resources related to the same webinar, you can mail us at mentor@fice.in. Thanks for viewing this webinar. Have a nice day.